Identifying hazards and critical control points is just the beginning. Now it's time to put safety into measurable action. In this lecture, you will learn how to set critical limits, clear, non-negotiable standards like time, temperature, pH, or moisture levels that determine whether food remains safe. You will also learn how to design monitoring procedures that are practical, consistent, and effective, ensuring that these limits are met at every critical step. Together, these tools form the backbone of a proactive food safety system that catches problems before they reach your customers. Objectives of the lecture. By the end of this lecture, you will be able to define what a critical limit is and why it matters, set measurable science-based limits at each CCP, create monitoring procedures to track safety in real time, understand who should monitor, how often, and what to do when limits are not met. What is a critical limit? A critical limit is the exact value or condition that separates safe from unsafe. It's the line you cannot cross at a critical control point. Think of it as a food safety red light. If you cross it, stop, correct, and fix. Examples of critical limits. Cooking. Chicken must reach 75 degrees Celsius, 167 degrees Fahrenheit at its core. Cooling. Soup must cool from 60 degrees Celsius to 21 degrees Celsius, 140 to 70 degrees Fahrenheit, within 2 hours. Storage. Refrigerator must stay at or below 5 degrees Celsius, 41 degrees Fahrenheit. Metal detection. Zero tolerance for metal in packaged goods. pH level. Pickled foods must be below pH 4.6 to prevent Clostridium botulinum. Each critical limit must be measurable with tools like thermometers or pH meters. Based on science or regulation. Easy to check during normal operations. How to set critical limits. Use trusted sources, government guidelines, food safety agencies, FDA, USDA, EFSA, WHO. Work with process-specific data. Consider the food type, equipment, and risk level. Don't guess. If unsure, consult a food safety expert or inspector. What is monitoring? Monitoring is how you check in real time that each critical limit is being met. You can monitor by measuring temperature, pH, time, etc. Observing staff procedures or visual indicators. Using logs, manual or digital, to record each check. Example: CCP, cooking, critical limit, must reach 71 degrees Celsius, 160 degrees Fahrenheit internally. Monitoring. Use a calibrated probe thermometer and record 1 out of every 5 patties in a log. If the burger reads 68 degrees Celsius, it fails. You take corrective action, recook and recheck. Best practices for monitoring. Assign clear responsibility. 1 trained person per shift should be in charge. Use calibrated tools. Thermometers, timers, pH meters must be accurate. Record everything. Logs create proof that you've done your job. Act fast. If a limit is missed, take corrective action immediately. Case: deli cooler failure. A small deli in New York failed an inspection when their meat cooler was found at 10 degrees Celsius, 50 degrees Fahrenheit, well above the critical limit. Their monitoring logs were incomplete. No one was assigned to check temperatures. Result: $2,500 fine and 3-day closure. Takeaway: monitoring only works if it's consistent, documented, and taken seriously. Monitoring plan example. Let's say you're monitoring 2 critical control points, CCPs, cooking chicken and fridge storage. Create a table for each. CCP, cooking chicken. Critical limit. The internal temperature must be at least 75 degrees Celsius, 167 degrees Fahrenheit. Monitoring method. Use a calibrated food thermometer to check the temperature. Frequency. Check each batch of chicken before serving. Responsible person. This task is assigned to the line cook, Jane, on each shift. CCP, fridge storage. Critical limit. The temperature must stay at or below 5 degrees Celsius. Monitoring method. Read the digital fridge thermometer and manually log the temperature. Frequency. Check the temperature twice per shift, once at the start, once mid-shift. Responsible person. The shift manager, Ali, is responsible for these checks and logs. Setting critical limits and monitoring them is where your food safety system comes to life. It's no longer just planning, it's action. Every log, check, and measurement protects your customers and your business.